Hi everyone, welcome back. Let's have a look at kites and rhombuses. First of all, some people struggle with what a kite is. I suppose if you see it in the sky and they're flying it, when I used to make kites myself, you always had this thing when you made a kite that those two had to be the same length and those two had to be the same length. Now these days people just buy them in the shop, but I used to make my own with my brother and send them up a long way. So you've got this pair being the same length and that pair being the same length. You can turn it sideways or upside down, but it's still the same principle. What makes a rhombus? I still like to talk about it as a pushed over square. So what's the basics behind it? All four sides are the same length. So that one opposite, that one is equal, that one opposite, that one is equal. Whereas over here, those two are equal, but these two are different to those two, but these two are the same as each other. Now, everything I keep on talking about is two numbers that meet in right angles. So when it was talking about a square, rectangle, triangle, all the different shapes, parallelogram, we're always talking about the two numbers that meet in right angles. So on this one, where are the two numbers that meet in right angles? Now it's often hard to draw because we're actually going to get that one across there, which we call a diagonal. So if I went across this one over here, because the formula's the same for both of these, I could go across there and I could say that's a diagonal. And then we look at the length of the diagonal. So if I go down this one here, let's say that was, let's make it easy numbers. If I made that, for example, 10 centimetres, all the way from this corner to that corner is just called a diagonal. So I'm going to use that 10. But if you look across here, if I put the other diagonal across there, even on a freehand diagram, you can probably see that they meet in right angles, and we're back to the two numbers that meet in right angles. Now here's confusing, except if I use different colour pens. The 10 centimetres means the blue line that goes all the way across there, whereas the black pen, I'm going to say this one looks like about 6 centimetres. Now some people will write it in the middle there to make it look like it's all the way across. Using those two numbers, they're the two numbers that meet in right angles. What are we going to do? Same as always. We're just going to say, I'm going to write it here. The length, I'm going to be a little bit fussy and write it long. Length of a diagonal times the length of, what's the words I'm going to use? The other diagonal. So, some of you are still saying, probably thinking you want the formula, but let's just go for this at the moment. The length of one diagonal, I'm going to say that's 10, multiplied by the length of the other diagonal, that's 6. Now I could do some mucking around with this shape. If I made it bigger, actually if I went all the way around here, we're back to rectangles again, just like with a lot of the other shapes, we're back to a rectangle. How much of the rectangle do I have in the kite? Magic numbers again, we're back to a half. So what are we going to do? We've got a half of the length of one of the diagonals multiplied by the length of the other one. So that's just a half of that. Now, you can half the 10, you can half the 6, you can't. If you want to, you can go 10 times 6 first, and then you can halve it. So I am going to go half of 10 is 5, and 5 times 6 is 30. Picking nice numbers, we didn't have to use a calculator. So that's centimetres squared, because we're using centimetres. Now, if I went for a formula, the formula is a bit unusual, that they start trying to think of something different. For diagonals, instead of going length and width and breadth and everything, they've just decided to call them X and Y. So here's the formula, those who like the formula. You go half times one of those, it doesn't matter which one. You can either go the blue one or the black one. So if I went the blue one first, I'd go 10 times 6. And if you wanted to, whatever way you want to do the calculation. If you wanted to, you can go 10 and 6 is a 60, and then you halve it and you get the 30. So it doesn't really matter which way you do it. So if I went to this one over here and I said that, let's make a nice number again. Let's say that's 12 metres. Now here's the annoying part. How do I draw this one on the diagram? There's another one that goes across here like that. And then I need to give a length to that. Now some people will do this. For example, they'll say that that's 4 metres and that's 4 metres. So they'll split it into two halves and they'll tell you the two fours, and then you know all the way across is actually 8. So if you're a formula person, you go to this half xy and you go, how far is it across that way? And that's 12 metres. Then you go, how far is it across that way? And that's the 8 metres, and then you can do the calculations. I like to do this still. Half of 12 is 6, because that makes the calculation easier for me. And then I can go 6 8s are 48. If that was metres, that would be metres squared. So if you're someone who's wanting the understanding, all you're doing is the length of one diagonal times the length of the other. So if I was out there doing concreting and I had a shape like that, I'd just go, okay, that's a 12, multiply it by the 8, and then one of the tricks you can just do is divide it all by 2. So let's go back to this and see if it worked the same as that one there. So you understanding? One of those, multiply the other, and then divide the answer by 2. So I could go, that's 96 divided by 2, because I know 12 eighths are 96, and a lot of you won't. Take your time, pick up your calculator if you want to. At that point, you can just pick up your calculator. If you wanted to, you can just pick up your calculator. We're going to let you use that for most assessments. So that one's just going to be 48. You can see I've got the same answer as there. The only thing that tricks people is sometimes they decide to put the numbers on the outside. So let's say I had a kite over here. Let's call that number 1. Number 2, let's go for number 3 over here. And if I decided to say, here's a parallelogram, a rhombus, much the same as the other one there, some people like to try to say something like this. I'll call that length there from there to there, and they might say that's, for example, 8 centimetres. Obviously it doesn't look like 8 centimetres. And then it gets confusing because they try to write the other one out here. I think it would be good if people wrote this, put one across there and said, for example, that's 4 centimetres. So you could write one of the measurements on the inside and one of the measurements on the outside. So what's the shortcut way for doing it? It's one of them, 8 times the other, and divide it by 2. So then you can go 4 eighths are 32 divided by 2, and that's 16 centimetres squared. So you can get pretty quick at it if you know what's going on. So on this one now a kite, because that one's the same length as that, and this one's the same length as that. And what a lot of people do is they put the separate numbers in here. So for example, this one, if I had that was 5 metres, that would be 5 metres, which would make 10 all the way across. Now, this is going to be smaller than that. Let's say that's 4 metres, and let's say that's 8 metres. So you've got to add up this time. So you go, how far across there? I don't know, sometimes it'd be nice to write on the side. So that's a 12 metres across. So from that corner to that corner, all the way across is 12 metres across. When we talk diagonal, sometimes it's better just to think of across. How far across? So from there to there would be 10 metres across. Therefore, if I get my area, I'm going to go the length of one diagonal times the length of the other diagonal, and then divide it by 2. So then I've got 120 divided by 2, which is back to 60 metres squared. But if you're a formula person, half xy, so it's a half, same calculations by the 12, by the 10. It doesn't matter if you put 10 times 12 or 12 times 10, and you're back to 60 metres squared again. Oh, I hope it helps.